Hello and welcome. This is a step-by-step complete building design using Protastructure. So what you are seeing is the architectural first floor level. Alright, so at first we will be carrying out what we call grid lines and column overlapping check. After we must have done with that successfully, you can see here is the elevations of the architectural drawings. Okay, here is the structural plan. We did this in the previous presentations. Okay, and then we proceed to Protastructure where we model this structure just like this. Okay, load it successfully, analyze and design it. Okay, you can see the design check right there as passed almost all the structural elements, after which we proceed to carry out interactive design. All right, where we interact with the reinforcement to ensure that we have an economical design successfully. In that case, we have to make sure that we click on interactive design and then we go straight away to make sure that the top bars are being lapped successfully, after which the middle bar has to be removed successfully since the top bar has been lapped to have an economical design. Click on the OK. So you will learn a lot of knowledge in these presentations. Stay tuned, stay connected. Don't forget to like and subscribe as we make progress successfully into this video. So this is the structural plan of these architectural drawings successfully. But before we carry out export from AutoCAD to Protastructure, we are going to be checking grid line overlapping and as well as column overlapping successfully. Before then, if you are not in the video where we create the structural plan, you see here is the video, so you can check out this video which will explain how we form the structural plan successfully. So let us proceed. At this time, we are going to be considering grid line check on this structural plan successfully. Why are we checking grid lines? We check grid lines to make sure we don't have grid lines overlapping. Okay, so what we do is you have to select one of these grid lines, right click, and then you come to select similar options, pick that. You see all of the grid line is being selected successfully. So with this, you can just hit or delete, okay, on the keyboard, or you use the tool to delete the grid lines. You see all of the grid lines has been deleted. Okay, simply means none is left. That simply means none is also overlapping. So you have to check all of these lines to make sure that they are not the grid lines. Grid lines should be a single line. All right, so I haven't checked that and it is corrected successfully. You just have to undo to get the grid lines back, just like this. The same thing applicable to the columns line. So you just have to select that. You can see all of this has been layered successfully and is well explained in that video. All right, so you select the columns line, right click on the keyboards, and then come to the select similar options to have all the columns selected just like this. You hit on the delete options to actually check if there are some overlapping columns. So we don't have any overlapping column, but we are having column line to have these lines here. Okay, but that is not an issue. Okay, so what you have to do, click on the undo to get the columns back successfully. You can as well delete those short line, which is this one. All right, you delete that up, and then there is a one here, this one, you get rid of that. Okay, that is a simple example of overlapping. All right, but that is not the full column line overlapping. All right, so now we are good to go. We are going to be converting this file to DSF. This is in the WG. Okay, Protastructure is capable of reading AutoCAD DSF format and not DWG. All right, so what we do, we just have to enter Z on the keyboard, or line for L for line, just like this. Enter. We want to look at the origin, okay, first, so that we can move this structural plan to the origin of the AutoCAD, so that as we export it to Protastructure, we still have it at the origin successfully. Okay, so I will escape and do that again. L on the keyboard for line and enter. Okay, after with 0, and then you do comma on the keyboard 0. Okay, and enter. So this is going to pick the origin. You can see this is the origin of this AutoCAD drawing environment. So move your hand up and click right there, escape, to have a line. Okay, zoom closer to the structural plan, highlight all of the structural plan. You can either copy or move. I will use copy. Alright, so I will trace the 2 points of this edge and then pick there, move it to the origin like this and place it. Okay, so after which I can get rid of this line and then this vault provisions. Okay, I actually provide this vault because over on the second floor there will be a beam that will actually run from this column to this column. So if you check very well with your dimensions, you will see that the beam length is going to be 8.5. okay, the beam length is going to be 8.5, and this is going to be a very deep beam. All right, so to get rid of such deep beam, we need to place an additional column at this point, along this grid line. Okay, and as well along this grid line successfully. So for us to do that, you just have to copy these 2 columns. Okay, and then pick it from that point, place it here so as to shorten the beam length. All right, okay, something like this, and then you have to dimension it now. Let's see what we having. Okay, 6.375. all right, so this has been shortened to 6.375, and this is fine. We'll go by this. All right, so after which we are good to go. Get the plan selected just like this. Make sure everything is selected. Everything is selected just like this. Okay, forget about the structural plans. Okay, Protastructure will not read it. So do W on the keyboard and then you enter. So you will have a right block dialog. In the right block dialog, instruction unit should be millimeters. And then click in the 3 dot provisions, and then it will take you to where you will save this file. All right. So we can save it inside 6-story, 6-floor school building. Okay? 6-floor school building. Just inside the document, you can see it there. But you come to file of type, options, and then in the drop down menu we choose DXF. Okay, DXF. All right, and then we can write it 6 floors right as the name right there, just like this. 6 floors. After which click on the OK option or save options and OK to have it created. So the file is being created inside document. Okay, 6 floor folder right there. Okay, so we proceed to launch Protastructure. So I'll have to minimize this file. Navigate to Protastructure on the desktop. This version 2022 we'll be using. Double click on it to have it launch. So click on the new options to create a new project, and then you give it a project name as 6 floor. 6 floors. So 6 floors school building as the project code, which is the project name. After which you have to select the code template. So we're using United Kingdom BS 8110. Select that one, and then after which you can click on the OK. But if you want to extract code from your existing project here, we use this project options, right? But we needed a new code, okay, from the code template. So we select United Kingdom option, click on the OK. So the code template is ready. If you check our project title here, 6 floors school building. All right, we proceed to import the DSF file that we have saved successfully. Click on the DSF import option, and then in the DSF import dialog, we will navigate to make sure that we are importing floor plans. Okay, there are options here. Is it a physical model? Is it an analytical model? We are importing, but what we're importing is floor plans. You can see right here. All right, so after which we will proceed to load the SF, and then we navigate to the 6 floor school building folder, and then here is the file that we save in DSF. Select that, click on the open options. So it is open successfully. So over here you can see we have grid, which is the member. We have column, we have wall. Okay, but at this point we really need wall, we just have to uncheck here. We wanted only column and grid right there. Okay, so after which click on the import options here. It is successfully imported, the grid lines and as well as the columns. You click on the close option. So here is the grid lines and the columns successfully. So here is the column sizes. Okay, but you don't need to worry yourself about these column sizes. We may change it after analysis, okay, if it doesn't pass design successfully. So what we will be doing at first is to rename the grid lines according to the architectural grid line numbering. All right, so the architect have these vertical grid lines to be numbered as Y1, Y2, Y3, okay, just like that, and then the horizontal is X1, X2. All right, so that's what we'll be doing. Okay, so get that selected, right click, and then you have to click on the properties. So in the property dialog, you should have A16. So you check for A16. So this is going to be Y1. Okay, then 12 right there is Y2. All right. The same way to have all the grid lines, vertical grid lines, renamed successfully, just like this. You close this axis table dialog. Then after which we come to the horizontal axis, and then we will as well label it as X1. Right click and then click on the property. So we go, the first one is A23, so this is going to be X1 like this, and then A15 is going to be X2. All right, and A20 right there is going to be X3, and so on, just like this. So after which you close this axis table dialog. Alright, so we have renamed our grid line successfully. After which we go straight away to save this project first. So only remember to save changes of your project successfully. So at this point we are going to be establishing our grid lines, beams. Alright, so for the beams you have to navigate to the modeling tab right there, and then you see you have beams here. Select it once. So in the beam editor, this dialog will be giving the beam weight. We have that to be 225 beam. We may increase this later, and then we'll have 450 as the beam length for now. So we are going to be running the beams, okay, from that point all the way to this point to have it inserted just like this. Pick it at the point. Okay, so after which you proceed to these provisions. Take the beams here. We have a beam running through these provisions and also from these columns all the way here. Alright, so for our structural plan, we are going to be referencing it so we can be able to have these beams placed successfully. But I am connecting to the columns, okay, that are quite very visible, just like this. But we reference the structural plan that we drew successfully. So having gone to this extent, we will navigate to AutoCAD. So here we go from what we have here from our AutoCAD structural plan. We have the beams here, two beams on this provision. So you connect these provisions, these two columns with beams, and here as well. Okay, so this floor we are modeling is the is the gallery floor, which is the first floor. All right, so we have another beam that connects here. Okay, here we have the staircase, so we have a cantilever beam just like this. So once you see this sign, okay, these symbols here, you know this is a cantilever. All right, so we are drawing a cantilever in Protastructure, and then you do not see these symbols, make sure that you activate it. All right, so we also have a cantilever being connecting this point and then connecting here. All right, so that is what we have in this area. Okay, so if you go back to the structural plan, we also have a beam connecting to this beam. Okay, so from this point we have a beam here. All right, that means from the structural plan there is no beam in these provisions. Okay, we delete that because this panel is not wide that much. Okay, so this is the area where we have the lift. We have the lift wall. Okay, so for the lift wall, we will proceed to use the wall of options. Click right there. In the dialog, we give it a width of 250, but we'll be using 300 millimeters lift wall thickness, and so the eccentricity is going to be 150 right here, and then this provision is 150. Okay, so after which our lift wall is starting from this point and ends here. Okay, so you pick that point, from this point to this point, and from here to here, just like this. Okay, so this is the lift wall successfully, after which we come over to this other side. So at this point we are going to be modeling the cantilever. Okay, so we have a cantilever here. We also have this is our wall, so you have to get rid of that. Okay, select this member, right click, and then click on edit properties. So we have a wall here. Okay, we have a cantilever there. We also have a cantilever right here. We also have a cantilever right here at this level. All right, so if you zoom closely, you can see this wall is the cantilever. Is the wall that is being carried by the cantilever beam. Okay, this wall. So we proceed to place the cantilever beam up to this point. It stops somewhere. It stops somewhere from what we have here. It stops here at this level. Okay, so we have another cantilever here. Okay, so since we have a cantilever beam here, it is fine. We also have a beam connecting this point to the cantilever beam. Okay, so the same thing applicable here. We need to connect here with a beam so as to add more stiffness to the cantilever beam successfully, just like this. So over to these provisions where we have a staircase. If you zoom closely to this provision, we also have a cantilever beam here as well at this gallery floor. So we have another cantilever beam up to this point. Okay, we have another one here, and then we have a cantilever beam here as well. After which, from this point to the last grid line, we have a cantilever beam here. So this is the staircase provisions. All right, the staircase provisions. So we also have a cantilever beam right here based on what we are having here. Okay, this is the beam here. So after the beam, we have also cantilever beam in this provision. Okay, so this is what we are having here. So now we need to connect the cantilever beams with beam just like this. So now we are modeling the first floor. All right, the second floor is going to take another shape. So this is typical example of what we are supposed to have. We need a cantilever beam here. Okay, but here seems to be a kind of convenience. Okay, a kind of convenience. So we get rid of that, and then we have a beam to connect this cantilever beam just like this, and then up to this beam, just like this, you can see. So this is the first floor, after which we will proceed to place the our slab, reinforced concrete slab successfully. So if we come over to these provisions, we have our reinforced concrete slab. But before we place reinforced concrete slab, we will have to proceed to enable our loading combinations successfully. Okay, so we have to save the project first. So you go to the loading right there, load cases and combinations. Click on the loading. So in this, we will have to apply it horizontal load, which is the wing load. We have that applied successfully. Click on the OK option to have the loading combination generated just like this. Click on the OK. Then we navigate to the modeling tab. We save the project first. Click on the slab right there. The slab dialog will be having a solid slab thickness of 150 millimeters. We have concrete cover 25. We'll come to the loading. This is a commercial structure, and so we'll be having an additional load of 1.2. This is an additional load. Okay. By the time we get to the other floors where we have the library, we also apply an additional load to the slab. Okay, for the imposed load for commercial building, you can see here communal, back on it. You can decide to use like hospital, ward, and school. Okay, we have offices for general use. Okay, so we can decide to use 2.5 kilonewton. Okay, after which we will proceed to insert reinforced concrete slab. So we have our slab here. So you just have to click in the provisions to have it placed successfully, just like this. Protastructure uses inline system to distribute slab load to the beams successfully. As you can see, some portions of the load in a rectangular and trapezoidal. Okay, just like this. Click here to have it placed just like this. So here is the reinforced concrete slab. I'm supposed to play this in all of these provisions, but I will use an insertion options to place it successfully. So I'll have to come back to this panel successfully. Okay, this has been placed also wrongly. Okay, we'll get back there. Right, so we need a reinforced concrete slab here. So we are going to connect here with a beam first. So let's close this. Select this slab, get rid of it. Select this one, get rid of it, just like this. Okay, we select this beam, we'll click on it properties, and then connect this just like this. Okay, alright, so here we are having a kind of a cantilever slab here. Okay, so we will use the insertion point for the slab. Select this slab, already created, right click it properties. So in the properties, we come over to these options, insertions. You can see beam region. So select this, and then we use pick point, or axis region. We use pick point. So we pick the first point, pick the second point, pick the third point, first point, to have this slab placed just like this. Same thing applicable here. So you have to clear this first. First point, second point, third point, the first point, just like this. Clear this again. Before you place it, you have to clear here. Okay, clear this one. Alright, so we need also slab here. This provision is for the staircase. Okay, this is the stairway provisions. Clear this. Alright. After which we will have to clear this, and then we will use beam region options, picking this provision, just like this. Okay, here we are going to be considering pick point insertion method. Like this, okay. Alright, we'll close this right away. So we can now have to see the structure in 3D. So for do that, we expand the structural tree, minimize the axis, can minimize the beams, minimize the slabs, minimize the shear wall as well, and then we can proceed to select on the story, one plan, right click, and then change to 3D view. So this is what we having. Alright, so this is what the first floor is going to look like. So in these provisions we have this stairway, which is the open well stairway in these provisions. Okay. So before we generate story, we are going to be setting the stories successfully. So for us to set the story, because Protastructure at the default story, we have it to be 3 meters. Okay, so you can see over here ST1, which is story 1, 3 meters. Alright. You select on the stories right there, you can right click and then click on the edit story. So over here, there are things I want to be showing you here in this edit stories provisions. So our first story is going to be, since we are considering 6 floors, our first story is going to be 2,800. It's not going to be 3 meters. But we can make changes to this later, so I can decide to as well leave it at 3 meters, just like this. So for the foundation depth, we are going to be using 500 because we are using piling. Okay, so we will have to excavate up to 500 millimeters or 450 before we make sure we tie the structure to the pie cap successfully. Okay, for the first story bottom level, I will be demonstrating, showing this. I will be showing you what this means. Okay, shortly. Then we'll come back here later to make some settings as well. Click on the OK options and then yes option. So at this point, we are going to be having some beams here from what we have in the architectural plan, a structural plan here. We are supposed to have a beam here and these provisions. So we can't have a reinforced concrete slab right here. So I can select this beam, right click, click on it properties, something like this we have here. Okay. I saw somebody coming from the normal ground floor level, we landed here. Okay, so the landing is going to be anchored to this beam. Alright, we closed here, after which we will proceed looking at the cantilever. If you check from here, from these green lines to these green lines is the cantilever. This point is where the cantilever lies. So we want to be placing a slab there. Okay, so for us to place a slab here, since we are already having a beam supporting the cantilever at 3 sides, what we will do is we will select slab right there, right click, hit properties, and then we will use pick point to insert the slab right there. So you have to clear these provisions first. Pick the first point, pick the second point, pick the third point, pick the fifth point to place the slab, just like this. Okay, but if there is a kind of railing activity, railing work here, you may choose to use the cantilever slab. So let me show you how to use that. The can select this and get rid of this successfully, after which you need to measure. If you right click and then you can see measure right here, pick the first point, pick the second point to measure that distance. So you can see 1.462. Alright, escape that. After which select any of this slab, right click and then click on a property. So in the type of slab right here, we are supposed to be changing the slab type accordingly, but Protastructure will do that automatically. Alright, depending on which edge is continuous or which edge is discontinuous successfully, just as applied in manual design. Protastructure does that automatically. We'll be using slab 12, okay, which is only supported by one side, okay, but in this case, this particular slab is supported by 3 sides, so it's not necessarily going to be a cantilever slab, just as I've said earlier. So this is what I wanted to show you. Alright, so what we do, this is supposed to work with slab type. It's supposed to work with slab type 3, okay, supported by 3 sides successfully, okay, but Protastructure will take care of that successfully. Click here to get rid of that, right click and then click on the property again. So clear this provisions, use pick point method. We have inserted it before, so we want to do that again because this is not actually a cantilever slab, okay. You can as well do that in the plan view. Minimize this, select this, right click, get to the plan view, just like this, okay. Select one of these slab, right click, property, clear these provisions, pick point insertion method, first point, second point, third point, fourth point. You have something of this kind, okay. Click on close options. Alright, so we are almost done with the first floor, which is the gallery floor. I click on this, click on the property of that slab, and then we'll have a slab in these provisions. If a slab is not placing, you use the insertion point to place it, okay. It is the insertion point options we are having. Clear here first, pick the first point, second point, third point, and then if you check very well, notice this slab is not properly placed, so we will correct that successfully, okay. Select this beam, right click and then delete that. Select this beam, right click and use its property in these provisions, pick that point and this point to have it placed accurately, just like this, okay. Alright, I wanted to show you the first story bottom level of this structure, so we'll come to the 3D so you can see it very much well. So you can see the difference between this line and this. This is the natural ground level and this is the first story bottom level, okay. So you can measure it to see what it is. Let's check the distance from this point to this point. You see it's 750. Alright, so that is the first story, bottom level is 750. So this is more or less like it is the DPC. So if I maximize this now, I will have to save this project first. I select in this provision, right click and navigate to the edit stories. So for the first story bottom level, I have that to be 750 right there, just like this. You can see. Click on the OK options, yes option. Alright, so we are almost done with the first floor modeling. Right click, select in that provision, so we have this, okay. Now we want to be changing this beam. Sections, we are using big sections 225 right there. We change it to 300 successfully, since some of this beam is going to be carrying columns, okay. So this particular first floor beam, we will change the sections to 300, okay, by 500 successfully. So for you to do that, you just have to come to this provision where you have your beams, select the first beams, scroll down, and then hold the shift key, select the last one to have all the beams in the building selected. Right click and then click on edit properties. So where you have 225 right there, selecting these provisions and then column wise edit. Here we change it to 300, just like this. Click on the OK options. Right, then for the depth, we will change that to 500. Okay, all right, click on close for now. So we have this. All right, so here is the vault that we are having in this structure according to what we have there in the structural plan. We have a vault here, you can see. All right, okay, so we want to be inserting stories. For us to insert stories, what we have to do is let me have to minimize this. You select here on the story, you right click and then you click on insert stories. At first we will go by 3 floors first, 3 floors first, so you just have to key in 3 right here. So to insert the story height, we leave it at default, we'll change that later. So click on the OK options and then yes option. So we have inserted stories above this. So we want to be generating story as well, so we can't edit this, all right, according to the structural plan successfully. So the next story is the story 2, which is over the cantilever, the galleries, story 1 that we have modeled successfully. So we can move the green line right there. This is the next story we are to be looking at. Okay, so this story is going to take another shape, so you need to pay close attention. Okay, so if you are watching this video from wherever, you make sure you subscribe to the channel, like, and then stay tuned as we make progress. Okay, so select story right there, right click, and then you will navigate to generate story. So in the generate story dialog, we have our source story to story 1, target story to be story 2. Click on the OK option. So we are moving all of the stories members type and then all the properties to the story 2 successfully. So click on the OK option, just like this. So click on the close option, so you have something of this kind. All right, by then we need to open an entrance into the lift or lift wall here. Okay, I will show you shortly how you can open that. We are supposed to open before we generate, so we just go up alongside. Okay, all right, so we make progress. So over here now, you can see what we are having here. We will have to navigate. We have to navigate to the story 2 that we just generated. At this story 2 we generated, we'll be having some columns and some provisions. Okay, like this point that we are having cantilevers, we now have columns there. Okay, so the column that we are going to be having right there, since we have changed the beam sections to 300 by 300, we use that column sections right there. So we will click on the column. In the dialog, we have 300 by 300 columns sections. Okay, after which we placed it here. Yeah, you can see the cantilever symbol is no longer there. Once you place a column, simply means it's being supported successfully, just like this. So we are doing this on the second floor. So pay close attention because we will do a lot of things on the second floor. We make a lot of changes here. Alright, so we have something of this kind. Also on this second floor, we have some secondary and primary beams that will cover the vault, because at this floor we don't have the vault. Alright, so what you have to do now, after having placed a column in all the necessary provisions, you select this beam, you right click and then click on the property. In the property, select these 2 points to have these beams of 6 meters. Okay, for the sake that this beam is 6 meters, you have to change the depth of this beam to 650. Click on the update and then use the same beam to place in these provisions. Okay, just like this. After which we will change. We have another beam connecting up to this point. The depth of this beam will be changed to 500, or you can maintain the same depth, but for the sake of economical design, you have this. You need to have this change. Click on the update and then you have another beam that actually goes across. At this point, we wouldn't have this cantilever, alright, although we generated everything, so we get rid of the cantilever first. This one, at this floor we don't have such. Okay, always pay attention to be sure that you connected your beam both ends to the grid line intersections. Delete that, save this project first. Select this, right click, click on properties, pick this point all the way here. Okay, just like this. Alright, something of this kind. You are good to go. Close this. So these 2 points, these 2 provisions, intersections, will be having column at the next floor. Okay, it's going to be carried the next floor. So at this floor also we have a cantilever here, here and here. Okay, so we have to select one of these beam, right click and then click on its properties. So by then I can decide to show you that we have a cantilever right there. So if you check in this 3D right here, you can see the design that we are having here. This is the first one, and then we have another one right here. Okay, so if you check from what we are having here, you will see that we are actually following the plans successfully. So this is the first floor that we have modeled. Alright, so for the second floor, you can see the second floor here. So we also have cantilever right around up to this point. So let's proceed. We have a cantilever at this point. We also have cantilever along this direction. Okay, so this is the cantilever line, this one, and we have something like this. So now we have a beam that will connect this. Alright, so you can see what we're having here. We closed. At this point, we are having reinforced concrete slab in this provision. So you select any of the slab, right click, properties, okay, slab thickness, the load are the same, but we may be having additional load as we will reference the architectural plan to see the activities that goes on the floor successfully. We place a slab right there. So come to the general, okay, pick point, change it to big region, and then you can be able to place it successfully. So this is run placement. So all of these provisions you may not be able to place as we used to. We are going to be using pick point options. If it doesn't work like this one, we are going to replace this. Okay, so close this, select this slab, get rid of that, select this as well, and then delete this. Okay, at this point we will use pick point. So select one of these, right click and click on it properties, after which come to this provision, use pick point options, clear here. So you can pick the first point, second point, third point, fourth point to have it placed just like that. Clear here first. The same thing applicable here. Okay. You have to clear these provisions. Let's do that again. Okay, clear this provision. Right, clear the instructions, and then place it again, just like this. All right. So we proceed to start the first concrete slab in this side. All right. So after which you have to close this project, and then we can now look at the 3D of this. So we select plan right there, navigate to 3D. So you see what we are doing here. So this is typical example of what we are supposed to have here. Okay, this is what we are supposed to have. So at this floor now, we may not necessarily have this column existing, so we are going to be editing that successfully. Okay, so you can see the difference between the gallery floor. You can see the difference between the gallery floor and the second floor successfully with the present cantilevers that we have actually created here successfully. So before we proceed, we want to be opening an entrance for the lift. Okay, so if you select this lift, you can right click on this lift options, and then if you check in these provisions, you can see wall opening. Okay, editor. So if you select in this wall opening editor, you can see what we have in here. What you just have to do, click on add. So the size of the door, or the width, which is these provisions, is 900. Okay, so what is the extent from both sides. I think this is centralized. So you now look at the height of it, okay, which is the extent is this x. You can see 3437.5, okay. Then the y is the 100, so the y is going to start from 200. All right, just like this. Then the height is going to take 2100, which is the headroom of a normal door, just like this. Okay, so you need to centralize this. Okay, so centralizing this, we may choose to increase this to maybe 450 right here. We are supposed to measure and know the extent. So if you click on the OK options, you can see it will be created here successfully, just like this. Okay, we can also get back to the architectural drawing to measure it, to make sure we centralize it correctly. Okay, if you come to these provisions, you can be able to check the distance from this point to this point. You are having 375. Okay, so 375, if you check it from the out, that is in. If you check it from the out, we are having 600. Okay, so let's get back there. If you right click here, go to edit wall. So if you key in 375 here, this is not centralized, but if you key in 600, it may not also be centralized. So we go by 450 because the wall thickness is changed here. Wall thickness is changed. You can see we have changed the wall thickness to 300 by 300. So it all depends on you, which is the structural engineer, to decide. Okay, based on their experience in design. So this is good. Click on the OK. So the same thing here. You add from these provisions, change here 200, here 450, here 2100. Click on the OK options. So you can see what we are having there. Okay, so from here we make progress. Let's maximize this. We will be modifying some columns and beams because the architect actually needs more space. It doesn't need any column to obstruct views, and then a space that will not be enough for activities. But we have introduced some columns here which is not on the architectural plans, so we have to correct that at this level. So before we correct it, we will get back to the architectural plans. So here we go. This is the architectural plan. The first floor, you can see the architect have only one floor, only one column here, believing that the one column will be enough. But due to this length, we introduce other columns here. Okay, so we want to be getting rid of some of those columns right now. Okay, at the first floor. Okay, and then if you come over here where you have the staircase, we will be introducing a column. We're introducing one column at the center here from the second floor. Okay, so let's proceed. So we will be getting rid of this column, this one. You delete that, you select this and delete it successfully, just like this. You can see we have created enough walkway or work provision for this gallery successfully. You can see now. So we have to effect the change here. Okay, so this beam that is splitted is not supposed to be splitted. It's supposed to be anchored to this column and this column directly. Okay, so we want to be correcting that. Select this beam, hold the control key to select both the beams and then delete it up. Yes, options to delete that beam successfully, just like this. Save this project first. The same thing, delete this one. You hold the control key and click on the delete options. Just for the provisions where we remove the reinforced concrete columns. So we also going to remove this column as well. This one. Select this and delete it. Alright, so we have something of this kind now. Over here, select this beam, control key, select both, delete. Yes, options. Pick this beam, right click, properties, pick the first point all the way here. So in this case, we are not going to split this beam. So click on the no options to have a place without splitting. Right click to get rid of that command, pick the next provisions. No options, we don't want to split it. No options. Okay, so this is what we now have here. Okay, you can see. So the same thing is applicable to this side. At this point, we are going to be getting rid of some of these columns successfully. Not this one, but this one. Okay, this, and then let's see this one. Okay, we can get rid of this as well. Likewise, the beams, you can hold the control key so you can select multiple of both the column and the beams successfully, just like this. After which, you right click, hit on the delete, options, columns, beams, selected. Okay, to get rid of that, select this beam, right click, hit properties, pick that point and this point, no options. Just like this. So we are trying to modify our model. Right. So you see what we've done now. Yeah. Okay. I said earlier we are going to be introducing a column here to support this span. Okay. So for us to do that, you can navigate to the plan view of story 2, just like this. Okay. Already we have a green line 6 here, which almost cutting the center. Okay. So we place a column here. So select this and then click on the property of that columns and place it at this green line intersections successfully, just like this. You can see. So if you get back to 3D service project, get back to 3D now, see what we have. You can see what we are having here now. Okay. Alright, so at this point we are going to be generating the next floors. Okay, we'll be generating the next floor and carry out some corrections. Alright, we generating the next floor and carry out some corrections. So let's check closely to see if we have any column obstructing views. Okay, so you have to be very conscious of the design you're doing. Alright, and make sure that you are also incorporating the mind of the architect into your design successfully, even as you are trying to obtain the structural integrity. Okay, so I think we are good to go by this. At this time we are to be creating a wall load. So we'll be creating a wall load before we proceed to generate these stories successfully. So for wall load, we are going to be applying wall load to all of these beams because we'll be designing for the worst conditions. Alright, so you select the first beam right there, you right click on the beam, so you see this provision edit load. Okay, these options we use, or you can also use this option you have here, edit load options, after having the beam selected. Okay, any of it works, so select it once. So load editor dialog will come up. So here we go in the wall load editor. I want to update this to 3D just like this. Okay, so we use wall load option, so select that. So over here we are going to be considering 3.47 kilonewton per square meters as the wall unit weight. Alright, plus finishing like the plastering. Okay, for the wall height right here we will be considering 4550. Okay, you may ask question, the wall height is, the story height is 3 meters. Okay, but if you subtract the beam depth, which is about 500, you should be having 2500. Okay, but we'll go by 2550 millimeters here. So you place the wall right there just like this. So after which, click on the OK options. So you can now see we have the wall placed successfully. Okay, you should also know that there are some walls that have windows placed on them. Okay, and so having been designed for the worst condition, most of the times you may decide to just overlook those walls and have them close up without opening the windows successfully. Alright, so at this point we will select on this wall, right click, and then we will be copying the copy load. Okay, so we use the copy load options to copy the load. So once you click here, you have this dialog, and then we will select on the OK options to have the load copied. You navigate to the structural tree and then select the first beam. This is story 2, so we are supposed to be doing that at story 1. So double click on the story 1. Select the first beam. Hold the shift click, select the last beam, meaning we are considering all the beams. Alright, we can check some of the internal beams. They may not carry wall load. You remove that manually. So right click, and then you can see paste load or Control V. So select that option, see all of the load has been pasted successfully, just like this. Okay. Alright, so at this point we are also supposed to inch this structure so as to reduce the moment at the fixed end. Okay, but we may do that later, because sometimes if you fix it during analysis, you may have some errors. It's only when you're having issues that it is necessary, but it has a way of reducing your moment, of which reducing your moment has a way of reducing your design reinforcement. Okay, so we will make progress for now. Later we'll look at that engine. Okay, so we are going to be generating this floor, this particular first floor, but as well you can still place loads here before we generate this floor to the next floor successfully, or we can generate before we place the load. Whichever way you want to do, you can do that successfully. Okay, so we have already inserted 3 floors. If you see over here, we have ST2 and ST3. Okay, so what we do, come to the stories, right click and generate stories options right here. We are to be taken from story 2 to story 3 right there. And then we needed all of these informations or members properties. So we have all of them checked successfully. Click on the OK options. Yes, options. Okay, so you can see what we are having here right now. This is actually what we are having. So we are going to be carrying out some editings here. Okay, so quickly we will move the grid lines to story 2. So double click on story 2 right here to have this grid lines here. So you just have to double click on story 3 to get the grid lines up. We will select this column, right click, and then click on the properties. We have one here, just like this. You can see we have another one here, we have another one right here. Okay, we have another one here. So we'll also be deleting some columns. As we are placing the new columns, we'll get rid of some of the internal columns. Okay, we have another one right here, and then we have here and here. Okay, so you can see what we are having now. We placed another column here. Okay, now there are some columns we need to get rid of here. Okay, this column we don't need it. We get rid of this column. Hold the control key to select multiple of that. This one, including this. Right, and then I don't think we need this one as well. We get rid of this. Okay, what is this distance? Let's delete this first. Get rid of this. Click on the OK option, and then these beams, we get rid of these beams. We don't need to split this beam. This one is not supposed to be split. It's not supposed to be splitted. This one is not also supposed to be splitted. And this one as well. So if you notice, we have selected the green line, so you have to select it again to get rid of that selections. We need to get rid of this beam and this one as well. So click on the delete options and OK options to have them deleted, just like this. So see what we are now having here. Click on save to save this project. Select this beam, right click, and then click on its properties. Pick this point, pick that point. No options because we don't want it split. Pick this point, pick that point. No options. Right click to get rid of this command, and then place another beam here. No option. Place another one here. No options. Alright, so we are making progress gradually. Sure, we are making progress. So you can now see what we are having at this floor right here. So let's check other side to be sure that we are very much good to go. Alright, also at this floor we may be having some column at the center of this structure. You can see what we are having here. Click on the close to close this dialog, and then we will navigate to the plan view. So here is the plan view. At this point we will be having some columns, here. So let's right click and check what is the distance we are having between discrete lines, that point and this point. This is about 2 meters. Okay, 2 meters. Okay, so this is story 3. So we now have to also check architectural drawing to see the activities that goes on here. Let's see what happened at the story 3. This is story 2. Okay, and this is story 3. So over here on the architectural drawings, this is the first story where we have the gallery. So this is the second story where we have to be library. Okay, so you can see the columns we are having right there. So we are good to go. Although this library will apply additional load. Okay, then we also have another library, the site. Okay, we are on point. So here we also have another. Okay, here is laboratory. Sorry, laboratory, 2 laboratory right there, and then library here, which this site is library as well, and then here is a sick bar. Alright, so we are on point. Okay, but we'll be inserting 1 column here to support. We have 1 column here, 1 column here, 1 here, so as to support this beam length. Okay, that's what we're going to be doing. So double click in this provision. This is story 3, so the column is going to be supporting story 3 from story 2 successfully. So the column is going to be section 300 by 300 millimeters. So this project first, get rid of the active command, and then we will select any of these columns, right click and click on the properties. We select it here, then change the property to 300 by 300 like this, after which click on the update. So you have something of this kind. You have another one here. Okay, so after which we are going to be splitting the beam. So we split this beam, so get rid of this beam, select all of that, get rid of this beam, these 2 beams. Right, this one are okay, the one in the vertical directions, delete these ones. Okay, options, just like this. Okay, now select any of these beam and then properties from this point to this point. Okay, and then all the way here. We don't want to split that. We have something like that. Okay, then from this point, from this column C35 to column C60 and all the way to this column C33. Select that. We don't want to split it. Okay, right, so here we go, close this. Alright, so click on the save option to save this project. You can minimize the columns member in the structural tree as well as the beams, and then let's view your structure in 3D to see what we've done so far. So this is what we have done so far. So we can now select this and copy this wall load, click on the OK, select this beam, right click, and then you paste the wall load right there. Okay, just like this, and then we can select That's story 2. Span the beam, select the first one all the way down with the shift key, select all of the beams successfully. So you can now right click and then you have to paste, copy the wall load successfully, just like this. Okay. So at this point, the story 3 design is going to be replicate for other stories successfully. So before we proceed to generating the third floor to other floors to complete the 6 floors for this structure, we will have to reduce the wall load by removing wall load from a wall that is not supposed to carry a load. Okay, so we start from the first floor. You can see the architectural plan first floor right here. Okay, we will navigate to first floor by double clicking on this first floor to move the green lines right there. You can see, and then we get back to the plan view of that floor. Here we go. On this plan view, you can see all of these beams are being loaded successfully. But if you check very well on the floor, you notice that this line has no beam. Okay, also this line has no beam. So we have to get rid of that by deleting the wall load that is on that beam successfully. By getting it selected, just select all the beams just like this, including this one. We don't need wall load on it as well. So you right click and see the little load options, and then over here click on the OK options to get the load on those beams deleted just like this. So by doing this, you are now designing for an economical situations, right? So if you don't do this, having these loads on this beam is going to over design this reinforced concrete beam successfully. So to avoid over design, you have to delete the loads successfully because the beams are not actually carrying any wall load successfully. So this is how it's supposed to be at the first floor, just like this. So we navigate to the second floor and as well make the same changes. Okay, so here is the second floor. If you come over here, we'll have a second floor. Okay, so all these beams, this one's here, does it have a wall load? This one, and this does it have a wall load? Okay, so we delete wall load from these beams. This one, we also delete wall load from this one. You hold this control key to select multiple of the beams successfully. So after which we will get rid of wall load as well on this beam. This one, just like this. After which we have wall load on these two. Get rid of wall load on these beams, just like this. Alright, also this beam here, we will get rid of wall load on that one, and as well this beam successfully. So you have to check critically to actually get rid of wall loads on the beams that are not supposed to carry wall load. So delete options, OK options to have this just like this. Okay, so on the second floor, on the third, that is the third floor, you get to the second floor. So this is the floor you're supposed to remove the wall load. Okay, so get all the beams selected. Just like this. And then we don't need to select that. Just like this. This one doesn't need wall load. Okay, after which you can right click and then delete load. OK options to have it deleted successfully. Just like this. So you check very well to be sure that these beams are not supposed to carry one load did not carry any one load successfully. So okay, options. Alright, so now we are done. The next thing we'll be doing is to hinge the beam. I will show you how to do that. For instance, you see this beam. This is beam, second floor beam 48. So you see, going upward is discontinuous. So you have to anchor it to the column. Okay, going downward is continuous. So there's no problem. But in as much as going upward is discontinuous, you fix it to the column successfully so as to reduce movement. Okay, so we select one, hold the control key, select multiple of this, just like this. Okay, select this one as well, after which I think we are supposed to, okay, here is a cantilever. So what we have to do, we also hinge all of this as well. Alright, so after which you right click and then you click on the delete one load, or sorry, we are hinging. So we have to get to, we go to where we have update beam end condition. So we will use hinge at right end. Okay, options, hinge at right end option, you apply the selected beam. So this has been hinged successfully, as you can see. So this is what you are going to do for to all of the discontinued beams successfully. After which we now proceed, navigate to the 3D, and then we will want to generate this model now because we are done with the engine. So we generate this model to the rest of the floors. Okay, and first we need to be moving this we need to load this floor first. Okay, so loading this floor first, we can select load. From that, right click, and then you can be able to edit the load, or you can as well copy load. If you use that option of copy load, you can move your grid lines to the story tree and then select the beams. After selecting the beam, you will have to select, come to the structural click, select the first beam, scroll down and select the last one. Have one of the beams selected, right click, and then you paste the load you copied. Having pasted the load successfully, let's maximize this. We will also have to navigate to the plan view. So on the plan view, it's not going to all of these beams that you will have the load placed on. So these beams does not bear one load. Okay, so we select them accordingly, right, to be able to get what we intended to get successfully. So having selected all of the beams just like this, make sure you get the right selection, after which you right click and then you delete the load. A way of reducing the load on this structure is what you are seeing me doing. So after which you can now navigate to the 3D. I want to generate the story now. So already we have gotten 1, 2, 3. Okay, so we'll be needing additional 3 floors. So you select in these provisions and click on the instant story. So here we'll be needing 7 floors. Okay, there's numbers of story. Each of the story is 3 meter. We did that shortly. After which you have that successfully, and then you come to stories. After the rest stories, so you pick the target story, then the source story, just like this, after which click on the OK option. So after which click on close, it's been generated successfully. Alright, so with this we have gotten the first, second, third, fourth, fifth and sixth floors successfully. But at the sixth floor we wouldn't need this wall load, right? So we get rid of the wall load. I will have to navigate to the beams right here. Select the first beam. I hold the shift key to select the last beam right there to have all of the beams at the sixth floor selected. Right click and then you navigate to delete loads, options, OK options. So you delete that, you have something of this kind, you can see. So now we will be navigating to the plan view of the sixth floor. At this plan view, we will select the members who will generate to the seventh floor. Okay, so a kind of a sheet over the lift well as well as the staircase room. Okay, so we will be having this column selected. Hold the control key to select as many members that you felt is part of the seventh levels of the structure. So these are the members that are part of the seventh levels, this one and this one. I will be generating all of these selected members to the seventh levels. Okay, from here. So I will come over here as well, select these members, next one, the columns around this lift well will be selected successfully. I will need this member as well, this beam, that column, that beam, these columns, this beam, this one, and this one. Then the lift well will also be generated successfully, just like this. Okay, I'll select that. So make sure that all of the members that are to be generated to the seventh floor is selected. Right, after which we navigate to the storage operations and then select generate story, and then we are generating from the source story 6 to story 7. Select that, click on the OK yes option. You can see selected members only. Okay, all have been generated successfully. Click on the OK options. So this is what we have. Alright, so over here you can see this is what we have. We need a beam here, so we can use one of these beam. Right click and then we will click on its property to connect this beam to this point. Alright, so now we see this is the topmost seventh floor. Okay, so we will close the stair room. Okay, have that provision closed, after which we will be applying wall load on this. This is not supposed to be a cantilever, so because the end is not free. Alright, so we will make it a normal beam by using the property of that one. Place it just like this. Okay, alright, we have this. So we'll be placing reinforced concrete slabs right here. Save this project first. Navigate with modeling tab, slab right there. Okay, so we have our slab just like this. We may use the property of the slab we created before, so we just navigate to the 3D. So the 3D is just what you will have. You can see here. Okay, so select one of these slab, right click and then in properties, and then you click in these provisions to have your slab placed just like this. Place it, okay, just like this. For the lift away, you're having a difficult to place it, we'll also place a slab here. Okay, if you're having a difficult to place it, there's no problem. We use an instruction options. Okay, so come to this instructions provisions and then click on the pick points. So I will pick 4 points to have the slabs placed successfully, just like this. You can see. Likewise, in these provisions, we'll do the same thing. I will clear this existing point I picked elsewhere. So I picked another point to have it placed. I'll clear this. To have it placed. Okay, so you see, we'll have something of this kind. The next thing we'll be doing is we'll be providing wall loads, these beams. Okay, so we can copy from this wall load, select that, and then select copy it, loads. Okay, options, and then select the beams, the intended beams that will carry the wall load. Hold the control key to select as many beams as you wish, just like this. You can see we may not have a wall load somewhere, or we'll delete some of that. Right click, I select paste options, so you can see we now have a wall load right there, just like this. Okay, same thing applicable here. You can move the grid line to the 6th floor, so we select that. All these beams that you wish to apply wall load, like this. Right click, and then you click on the paste loads. Okay, so we'll have this successfully. Alright, so having done with this, we want to check this structure critically. So if you check this structure critically, you notice that this beam actually did not transfer load to this column right here. You can see. Alright, the beam doesn't transfer load, so we are going to be getting rid of this beam, so we can connect a beam that can evenly transfer load successfully. Alright, so we select this beam, that one, select this one, select this one. All of these beams are the same. Okay, even including this one that is up right there, it's the same. So get rid of that. Okay, by clicking on the delete options and then OK options, you have that deleted. Okay, now I want to be creating a beam, so you just use the property right there, pick this column here, put this one here. We say yes to split it. Okay, so the load can be transferred evenly. Okay, to this column can be shared with these columns. The load can be shared between these 3 columns, the load on this beam. Okay, so that you can lift these 2 columns. Alright, so this point I want to be generating this beam, but by 10 I'll select this one, copy wall load. I'll copy wall load because I will explain something to you now. Copy loads. Okay, options, select this beam, these 2 beams. You right click and then you have to paste the wall load. Okay, so now this beam is different from this one. Alright, so this beam is more or less like a simply supported, and this is a kind of a continuous beam. Alright, so that is why we need to make it that way, so the load can be distributed evenly. Alright, so we make progress. I will select this beam and this one, and then I'll navigate to the set out, and then I'll get to stories, and then I'll generate this. So I will be generating this. We are at, okay, let's move the grid lines. Let's move the grid line to story 2. Okay, so that we have that as our source story here. Alright, select here, and then control key, select that. After which you go to the building set out, and then you select and generate stories. Okay, So we are to generate this for story 3 and then up to story 7. Okay, so it is being marked that that beam is created as story 6. You can see what we are having here. All right, you can see what we're having here. So let's just get rid of this. Okay, and then let's get rid of these beams by deleting it up, just like this. Okay, let's save this project first, then after which we will now have to use any of the beams here to create another beam, just like this. Let's close this dialog and then select here, copy it, load, after which select copy, load, options. Okay, options, pick this, control, pick this, right click, and then you paste the copied load successfully, just like this. Now get the beam selected, so we generate it to the 7th floor right there. So we navigate to the beam set out, and then we have story operations. Then we generate this. You can see now we have our source story to the story 2, and then target story is going to be story 3 up to story 7. All right, and then after which click on the OK option. Yes, options. Okay, after which close that. So we have something of this kind. Okay, so this load, we have to get rid of it by selecting it and then select delete load options. Okay, just like this. Okay, so this is what we are intended. All right. Okay, so having modeled this successfully, we will now have to proceed to save this project. So in this video we'll also be running analysis, but we want to check the structure critically. All right, so we will navigate to the plan view so we can check this structure if there is any beams that is not well placed successfully. At this floor everything is fine. Let's check the 6th floor. Okay, at the 6th floor everything is also good. At the 5th floor I think everything is nice. There's no beam showing a cantilever sign, so you have to just be conscious of the modeling successfully. At the 4th floor is the same thing. Let's go to the story 1. Okay, so this is what we're having. All of these cantilever beams, you can see all of these carrying these signs, cantilever beams, all right, around this provision successfully. Okay, so let us get to the materials. So we select on the materials. So we'll be using this concrete strength. For the steel grade, we will select from here so we can set the steel member diameter. So here for the columns, we don't need 10, we don't need 13. Okay, we will be looking at 16. Okay, you can see, and then 20. All right, we have 25 as well. Okay, just like this. Okay, so for the walls, we will need 10, 12, okay, and 16. We may not necessarily need okay, let's just add 25 in case of necessity. All right, so for the beams, we are not going to use 10, we're not going to use 30, we use 16, we use 20, and then we use 25 as the highest pad diameters. All right, for the links, we are going to be considering 10 and 12. Okay, it's 10 and 12. All right, so the program is going to choose 10, okay, for the links successfully. So whichever members for the foundations, we will have 12, and then we will have 16, and then we will have 20, 25. All right, just like this. Okay, for the reinforced concrete slab, we will have a 10, 12. We have 12 right there. We have 16. Okay, we have 20 right there. Get rid of 25. The rest of that. So with this, we are fine. So click on the OK options. After which, you click on the OK option again, and then Okay, we have done with the material settings, so click on this save options to have the project saved successfully. So after which we will navigate to the 3D. Alright, so this is what we're having. At this point, we are going to be checking this project if there is any error in our modeling. Okay, so we will navigate. You can navigate to the display options or the display options, and then you refresh these provisions. After having that provision refresh successfully, come to review options and then see building model check. Okay, so you select on that, click on start. So this is going to check if there is any error. So you can see building model check completed, numbers of errors is 0. Okay, so you see in this our model we have 0 error modeling. Okay, so you can see how good we have done this modeling successfully in this project. Should in case you want a full and complete training in Protastructure, concrete and steel, you can as well reach to us through our contact in the description of this video. All right, and we will train you completely. Okay, so this model have no error in it, so click on closed. After which we will be looking at analysis. Okay, we will be looking at analysis. All right, so for us to do analysis or to analyze this structure, we navigate to the analysis tab, see building analysis. Okay, the building analysis. Okay, we have to navigate to the loads. See here we have wind and story. Okay, but in the loading combinations you have to check that first to see if we have actually selected the horizontal loading. Okay, because the project is about 6 floors, so you have to enable horizontal loading. Okay, this is this wind load. Okay, you enable it from here. After we click on OK options. Okay, again, then you come to the wind and story loading. So in this wind and story loading, you have to get to wind calculator. In the wind calculator, the wind speed in this area is 30 meters per second. So these are the things we're going to change. Okay, for the terrains and surroundings. Okay, we leave this at default. All right, and then this is a reinforced concrete structure, which is a building category. You can see here. So if you select in these provisions, you see steel, composite, ROC, tower, or chimney. All right, so we get that selected. You apply that first. If you want to print a report of this, you can create a report through the provision, but just apply it. Okay, after which you click on the OK options. All right, so we have applied that successfully, and then we proceed to the analysis tab. We have already checked this project. Okay, and then we have no error in our model. All right, so you just have to click on the building analysis. So we click on the building analysis. We wouldn't want to design any members, we only want to analyze. Okay, so click on building analysis options. So we will give the program some seconds to carry out the complete analysis of this structure. Okay, so you can see building analysis is done successfully. Building analysis completed successfully. Relative story draft satisfied the limit in direction 1 and 2. You can see what we model successfully. All right, so we will click on the OK option. All right, so after which we will close this dialog. Now we want to be designing the structural element, the columns, the beams, but as first you have to start your design from the foundation columns up to the last floor's column successfully. So how do you do that? You will do that by navigating to the story one, which is where we are. So select the column itself, right click, and then you see ROC column wall design. Okay, not active story options, but this option gives you all the columns. All right, but the second options, active story, is what we are going to be using. You can expand this. So these are the columns, they are not being designed. That is why you see here it's just empty. Steel bars is empty. Supply steel is percentage is 0. Utilization ratio, all right, everything is blank. So we want to design it. You click on the column design bash mode. So in the column design bash mode, you can select reselect all bars and click on calculate. So you see process completed. Okay, yeah, click on the close options to have all of the columns ROC column designed successfully. All right, so you can see U ratio. So one U ratio is more than 1, that column has failed design. Okay, one U ratio is more than 1, the column has failed design. So you have to check your U ratio is very, very important over here. All right, so now we see the maximum U ratio I'm having here is 0.84. Okay, and then if you check the columns, you see supplied percentage of steel is 4.3. Okay, which have the highest percentage of steel supplied. Okay, and then you check here steel bars, you have 4Y25 and then 2Y25 and then 2 times 2Y25 right here. Okay, the sections is 300, okay, by 375 right there. Okay, so over here you can see we're having Y10 for the links. Okay, for this ISU ratios. Okay, which this column carries the most load. Okay, this column carries the most load from this structure. Okay, so this is column C1. Let us look at that column. Okay, so any column that looks critical, you have to take time to look at it. This one is 0.81, while this one is 0.84, which is the highest. Okay, we have another an highest here, which is 0.89. All right, this one seems to be highest. Okay, so let's look at these two columns. Okay, 1C8 and 1C1. So we are done with this design. Okay, but let's look at 1C8 and 1C1 where they are. So we'll close that, and then before you should check that, you have to navigate to the plan view so you can see it very much well. 1C1, I select it from here. Okay, here is the column. Wow, okay, the column that carries the cantilever. Okay, carry these two cantilevers. Okay, and other part of this loads from the slab here. Okay, then 1C8, 1C8, where is 1C8? 1C8, this one is 1C8. Where is it? Okay, see one on the standard columns as well. All right, so these are the two columns. We are done with the design of the first floor columns, first floor to foundation columns. Okay, the walls has also been designed, as you can see. Okay, after which the next thing you design is the beam. Okay, so you select the beam, right click. You want to design active story beams. Okay, so let's check to see the beams that has failed and the one that has passed the design successfully. So at this point, maximize this, go to the beam design bashed mode, and then reselect all bars, click on calculate, and yes, options. Okay, you give it some time to carry out the design successfully. So we can also check the information's content, design results right here, and then we will be able to know which of the beam is stressed up, and then we see how we can apply some stiffness to the beam. Okay, to see that all of the beam has passed design successfully. Click on the close options. Oh no, unfortunately we have this beam failing, next one. All right, so all of this has actually passed very well. There's no more stressed except this one is stressed up. Okay, this one is stressed up. You can see the U ratio is 0.9996. Most of the beams are being stressed up. Okay, so these beams that are U ratio 0.9, we are going to be increasing the depth of these beams. Okay, we increase the depth so the U ratio can reduce. Okay, for this one that has failed, let's see interactive design. Okay, so click on the OK options. So this is going to open up the interface where we can interact with these beams. Okay, so design is not valid. Do you want to update rebars? Say yes. Options, let this be updated. Okay, all right, so this has been updated. If you check very well, you can notice that the links, the shear reinforcement has failed. Okay, failure is at the shear reinforcement. And then what could cause a shear reinforcement to fail is the depth of the beam not being enough, okay, for the load it is carrying. Okay, it will cause the shear reinforcement to fail. All right, and here the size and the spacing, okay, of the bars are too narrow. That's why I'm having this red sign over here. All right, because we are having 4y25, 4y25, so it is too narrow. All right, so what do we do at this point? You have to increase the depth of the beams. Okay, so to increase the depth of the beam, you can come over to this provision where you have beam options. Okay, so this will show you the beam systems, okay, that we have in this provision, just like this. Okay, so now having this, now we can change this to 600. All of these beams, just make them 600. Okay, make all these beams 600, depth 600, 600, 600 as well. Okay, because this is the first floor beam, so we will give it a good depth just like this. After we click on the beam design parameters and then click on OK options, come back to the rebars. Okay, so you can see that that red sign you are having here is no longer there. All right, because we have increased the depth of the beam, so the shear reinforcement has actually passed design successfully. What we are having here is just the spacing. What you do to this spacing, you can add another reinforcement here. Here seems to be a cantilever, so you increase this reinforcement to y20 and then make it like 3 or 4 options of that. Okay, after which you could, to correct this, you have to make this one a kind of first layer bar, and then this one now is going to be a second layer bar. Then here you have to expand it all across the lab just like this. Then over to this one, you have to also lap it and lap this as well. Okay, so you see we have corrected the top part of that. Then for here we are having this, you need to make it second layer bar, and then this one you need to lap it as well to correct this space issue. You can see it there. So over here we are still having some space issues here, so we can reduce this reinforcement. As you are reducing, be checking the area of reinforcement up here. So if it won't, so it will affect it. You can reduce this diameter of reinforcement, increase it. Yeah, so over here you see we are also having a kind of support reinforcement here. You have to make it a support reinforcement so you can correct this. Okay, so you can see what we are doing right there. So the same thing applicable to these provisions. This is a support reinforcement, you make it a second layer reinforcement successfully. Okay, after which there are other editing we are supposed to carry out here successfully. Okay, but if you are in our mentorship class, we will take time to teach you all of that successfully. But I've done some part of it here. So click on the OK options, and then you see this has actually reduced. Okay, this has actually reduced to 0.82. Right, but this the failure sign is still there. Okay, so we have to refresh this to have the failure sign. If you get back to the interactive design again, say no to that, you will notice that we are only having a space issue here, a space issues there. So we can't this space issue, I think, is from these provisions. You can't extend this to lab. Okay, and extend this to lab as well, just like this. And then over here, so this sign have to be removed. You can use increase this reinforcement to 3. Okay, can see now we have that sign being removed successfully. That red sign is right there. Okay, so with this, everything has passed the design successfully. Can click on the OK options. Alright, so one thing in Protastructure, when a beam failed and then you have corrected the failure, you have to refresh it. Okay, so to refresh it, you need to do that at the Protastructure interface. Okay, there's a provision to refresh and it will correct here. Okay, so we are done with this beam, although there is still an interactive design process. Okay, but we explained that deeply in our masterclass. Okay, so you have to close this now. So we have successfully designed the beams. You can see that beams that we are working on this one. Let's also refresh here. Okay, we have refreshed that. So we navigate to the story 2. Double click on story 2, and where we have these members as story 2, where we proceed and then we navigate to the column first, select it, right click. We have not carried out the slab analysis and design. Okay, but we will do that. All right, so come to the active story. Okay, the active story of story 2, see none of the column has passed. All right, so what we do is that we will come to these options. So we select all bar, click on calculate. So process is completed, click on close. Most of these columns are under high pressure. Okay, so you can see this one 0.96 U ratio, which is almost failing. Right, so in that case you can't increase the sections of this column, okay, so as to reduce the stress on it successfully. So these are the columns. This is what we actually called the interactive design. So if I want to do that, I'll select this column right there, click on interactive design. So this is take us to the interactive design interface, where we can be able to adjust this column section successfully. Alright, so you can see now that we have this, and this column is 300 millimeters by 300 millimeters. So we can have one side to be 350, and the other side is 300, 350, just like this. And this other side is 300. Click on the update, you have something of this kind. Okay, so after which you will just have to click on the interactive design. Yeah, so you can see you have 6y20. Okay, at area of steel 184.96 millimeters square. Okay, with a 1.80% percentage supplied. Okay, click on the OK options. So we are having about 0.96 U ratio. Okay, but let's see now we have changed this section. Let's see what we have. Click on the OK options. So you can see now this is the beam 0.98 U ratio is what we are not having now. Okay, but you can still work on that. You click on that beam, we only change this side. We can as well change this thickness to also 350 by 350. Okay, click on the update. Alright, and then you can interact that design. Now we are having height Y20. Okay, and then you see the area of steel have reduced. Okay, so click on the OK options, and then we can't click on the OK options again. You see what we are having as the ratio from 0.9, it falls to 0.7, meaning at this point, at this level of U ratio, that column is able to carry the structure comfortably. So this is how you interact with columns here successfully. So you see C2C37. So you have to check this column at the first floor to make sure that the section at the second floor is not bigger than the sections at the first floor successfully. Okay, so that is what you will check. I just use this for example to show you how to carry out interactive design. I'll close this right away. So the same thing you will do to all of the floor after you must have done with your interactive design. You will now be looking at the foundation design successfully for this project. Okay, So in this next video, we will be looking at the foundation design of this project successfully. Stay connected. Don't forget to like, don't forget to subscribe to this channel of raising. Okay, and then if you have any questions, you can drop it in the comment sections as well. So you want to reach to us for a personal masterclass in this program, our link is in the description of this video. You are very much welcome, and you will enjoy the training process successfully, and other material we will give to you. We take you through manual process. Okay, so that is how we train our students. Okay, at this point we want to stop here to be continue the foundation design of the structure in the next presentations. All right, stay connected and bye for now.